Hello, hello, hello. I think we're hopefully live on YouTube. We'll give it a moment just in case we're not, but it says we're live, so we probably are. Welcome along. This is the last in the podcast interview series of the first season, but it's also the first of the live Q&A events that we've ever done. So there's a decent chance that this is going to be an hour of. Can you hear me? I can hear you. Can you hear me?
Yes.
Bear with us if that's the case. We'll do a little housekeeping before I get too much further along. For those of you watching on Google Plus, you should have a box to the right of your screen with the questions in it that people are submitting. I noticed quite a few of you have submitted some questions. If you haven't submitted a question, then please do. But if there's a question on there that you like the look of, you can click the +1 or the plus whatever number it is, and the most popular ones will float to the top. We'll pick one in a minute and get started. But we've got a pretty full panel today, as you can see down the bottom. So we'll not be getting too deep into any questions, but we'll try and rattle through a few. If you're watching on the YouTube link, which I hope is working, has anybody down the bottom managed to check? No. I'll check. If anybody's watching on YouTube, then there'll be a overlay in the bottom left-hand corner prompting you to jump over to Hangouts. If you've got a Google account and you're logged in, then it's working. If you want to jump over to us on Google Plus from YouTube, just click that overlay and it should jump over here, and you can do the questions and things. Otherwise, if you're happy just watching, then you can stay on YouTube. There are comments down the bottom which I'm going to struggle to keep up with. To be honest, I'm juggling plenty of balls here, and I'm probably going to drop them all. But I'll try and keep on top of them. As I say, we've got a pretty full panel in the order that they show up on my screen. On the left on my screen, well, we've got Fred Mendonça from ESI Open CFD. Hey, Fred.
Hi.
We've got Haysam Taleb of Optimad.
Hello. Hello to everyone.
We've got Jeff Waters.
Hi.
Sales guru. We've got John Chawner. Or is it a
Good morning.
Aha. We've got Haysam Taleb. Sorry, we don't Haysam. We've got Karen Fassis.
Hello Robin. Hello everyone.
We've got Patrick Hanley.
Hello Robin.
We've got Wolfgang. Although Wolfgang was having a problem with his microphone, so he might be doing this by the. Oh, hey, Wolfgang's here.
Do you hear me?
Yeah, we do. I thought we might have to do this by mime. But no, thankfully not. I put a couple of icebreaker questions out to the group, and I had a little bit of feedback from a couple of them. Well, Jeff in particular, he reckons he's got a cracking answer to this one. So I'm going to start with this question, and then I'll catch up with what questions you guys are answering, and we can see what's next. But I asked the panel what tech they thought was going to come through for CFD and be revolutionary or groundbreaking, or what was going to be important that perhaps isn't now, but is coming through. Did anybody want to kick that off? No. Oh, Wolfgang's got his hand up.
Do you hear me first?
Yeah, absolutely.
Yeah, okay, excellent. Now it works. So, I just throw it in. I'm not an expert in that, but I went to 5 or 6 CFD conferences in the last 6 months or so, and some of the presentations started with presenting applications, so apps. So the whole app area seems to be gaining ground. Even ISV software vendors, they are coming up with what they call, XYZ server or XYZ app. So they come up with a complete list of applications, which is basically based on their code, but nicely customized for a very specific area, like turbines, for example, fans, for example, etc. So I throw that in. I believe this gets more user-friendly. It is very easy to use. You only have to tune a few parameters, and here you go. So almost anybody now with without a big, deep knowledge about tuning code, running code, organizing, managing code, etc., can use it. Okay, so I hand it over to you.
I agree to some extent because several years ago I bought the domain CFD apps, hoping that, predicting that apps would be big in CFD. But as far as technology is concerned, I think quantum computing might be interesting. So it could be about 3,000 or 1,000 times faster than supercomputing. IBM has a cloud-based quantum computing working, 5 qubits. I joined, and I'm trying to program a quantum computer.
Oh, awesome.
Well, so I have an interesting one that I've been thinking about, and I have to lead this with an admission that yes, I'm a blogger and a podcaster on the CAE front with lifeupfront.com, but I also work for ESI, and one of the technologies that ESI has recently invested in that I think is pretty exciting is this machine learning and big data analysis. And I don't know exactly when this is going to hit, but it's something that I see as a big technology, along with something like quantum computing or at least cloud computing. If you look at the history of CFD when it was first commercialized, I think we can all safely say that we were talking about doing ones of runs per, let's say, average design process around a product. In the late 90s, we started pushing into maybe doing tens of runs, although I think everyone here knows that a lot of CFD engineers still do ones of runs per average product being developed. So the software out there has all been priced around this kind of model as well. When we move to a jump step, which I think is coming to thousands of runs per or more per average project that's developed with CFD, we're going to have such a glut, like terabytes of data, that we're going to have to read through. And that's where I think something like what powers Facebook and Google, everywhere you go on the web, you're leaving a little footprint, and all that is captured. And these companies use big data analysis today. They have been for a long time to uncover trends and important operating points. And I think that we're just going to apply all of that to a much, much bigger data set. And so that's the big trend that I'm looking forward to. So if you imagine, doing aerodynamics around a car, I think you'll start to take into account a much, much bigger design space than what we do today. And in order to tease out the important connections in all that data, it'll have to be done with machine learning and not and big data analysis, and not a human.
Hey, Robin.
Yeah.
I'm not one much for picking winners, and the reason is kind of simple. I think everyone on this panel, in response to your question, could probably come up with some really good ideas and projections of technology that over time will prove to be successful in certain market segments or industries or applications. And that's the challenge of trying to pick winners, and why I don't like to do it is because the technology will be unevenly applied. Some apps, great. That will solve problems for some people. Quantum computing, excellent. Other users will find that to be extremely valuable. And we could go on and on down the list. So I think it's a matter of kind of trying to ride the wave and the evolution of the technology rather than trying to pick what the next revolution is going to be.
Yeah, I heard a good quote about picking stock winners, that the best indicator of future price is current price. So I think that is a similar thing to what you're saying now, that it's evolution rather than revolution.
Yeah. The simple reason is we have invested so much money, so much time, and so many people into what we are already now are able to do now. I mean, you know, imagine our 3D time-dependent and all schnick-schnack contained software we have. You cannot easily throw this one day to the next on a quantum computer. I mean, imagine how much investment it would be to port, I mean, the 250 most important CAE codes to a quantum computer. I mean, that is not that is not possible. I mean, evolutionary, yeah, you can port a piece after a piece. So that would simply taking CAE, for example, as a whole to a quantum computer, that would be not possible.
IBM wants us to start doing it now. So by the time it goes up to about 50 qubits, we'll be all set to go.
Well, that's very true, because that's one of the essential comments in the CFD Vision 2030 study, which everyone probably wishes I would stop referring to.
I was going to say, well done, John. You got this far in without mentioning it.
But they talk about the fact that you know, CFD software needs to start evolving or be architected in a way that will allow it to evolve to whatever the next generation of exascale platform is going to be. It's rather than saying, you know, it's going to be quantum, or it's going to be bio, or it's going to be graphene, or whatever other fancy technology they come up with. The call is to say we need to start now to architect our software in a way that allows it to be amenable to porting to whatever new technologies come along, whether that's modularity or different programming techniques, that we need to start heading in that direction without really knowing where we're going.
Yeah, just get something to work on a very small scale.
Yes.
Well, actually, if I might say something to this topic regarding, let's say, exascale computing, or also the apps that Wolfgang referred to. Well, actually, I believe that, I mean, everyone who does CFD, I think, should also be honest about the limits of CFD. I mean, there's a big potential of generating a huge amount of data, but actually, we still struggle about validity of this data, about how you really can use them. And I mean, just generating even bigger amount of data without really knowing how to use it, I think it is technically possible, but I don't think it will make much sense to industry until there won't be a much larger convergence of different sources of data. So imagine, okay, I can do hundreds or thousands of simulations in my design cycle, but if I cannot correlate them as easily as I generated them to experimental data, to distributed sensors, or things like that, I think it will be a little bit useless in to some sense.
I usually think that before you generate the data, you usually know how you're going to use it. For instance, if you're doing a stability analysis of an aircraft, and you have to run several runs with several control surface deflections, you have to set that up first, and by the time the data arrives, you already know exactly how it's going to be used.
Hey, Sam, I think that you just touched on an important point. Another one that I'm curious to see how it's going to play out for CAE is collection of sensor data, real-world data. I predict that we're going to see a lot more of sensors. So, okay, big buzzword, the Internet of Things. Okay, last time I'll say that, but I think we will get a lot of real-time data that's coming back from the field that's going to, in some way, mesh back with the original models and help to improve them.
Karim, were you going to come in on that? Because I think you do you have an aspect that collects.
Yeah. So very interesting discussion. I was thinking that generating data, a good application for our industry. So we are very industry focused. We are mostly focusing on the wind power industry. And for us, it's true that we see, but that will come at a later stage, I believe. The fact that using generating as many simulations as we want at the same time, thanks to the cloud computing, for instance, and in the future some other sources of parallel computing, is already a huge revolution to solve a lot of performance issues. And at a later stage, it will be also interesting to generate such amount of data to go towards what we call uncertainties quantification. That could be a really great added value to start also using this new way of calculating to basically preset an unlimited number of scenarios before running the simulation at the same time, so that you feed an uncertainty quantification models that helps you in your design. So I believe this is true for the wind power industry, so that would be true for a wind power project, for instance, and I believe it would be true for also some other industries. I'm just throwing it like this, but I guess it is like this.
Well, because of the way that this bit of the conversation has gone, I'm going to actually select one of the questions that's come in, because John's already mentioned his NASA Vision one, but I know another one that gets John going a little bit is the democratization of CAE. So I'm going to pick that question, because we're also talking about verification and validation and things like that. So Marcus Rademacher sent us a question in that says, as a CAE analysis, I'm skeptical of the whole democratization of CAE, but not just because it would threaten my career. I'm concerned because CFD and FEA are not robust in that you can get wrong answers and not know without verification and validation. And then throws that out for thoughts to the panel.
Well, I'll take that one since you kind of led me to it.
Yeah, sorry, John.
I wouldn't feel threatened by democratization or skeptical of it, because, I have gone on record as mocking that word, but the actual sentiments involved are probably what we should be doing all along. I mean, Wolfgang touched on this a minute ago when he talked about making vertical apps or CFD apps that target specific classes of geometries, whether it's turbines or external automotive aero or whatever. First of all, by casting the application in that regard, where it has a narrow area of application, you make it more robust and easier for non-experts to use. The questioner said the methods aren't robust and you can get wrong answers and not know it without V and V. That's the key. If you're using CFD, it is your responsibility as a user, regardless of how easy we've tried to make the application, to have done your own verification and validation, to know what you're using, whether you're using it properly, what its range of applicability is, that you've run it on benchmark problems, the whole bit. And as a matter of fact, you guys will get a big kick out of this, is that through the Assess initiative, I'm kind of getting more closely involved in the whole democratization issue.
But if I give a comment to John's answer, I mean, I totally agree, but I don't think that anyone who's going to offer his, let's say, CAE services through the cloud will ever put a keynote and will say, take care because the results may be wrong. I mean, it's a marketing issue. So everyone says, whatever you do, you get the right answer.
No, that's I believe that now with the cloud, you can be really transparent with this. You can say, hey, here's just a modeling chain. You can play with the input, you can play with the outputs. Now, you have also access to unlimited calculation power, fully elastic. So yeah, it can be said that we have just put up a platform, and we are not guaranteeing the results. We're just providing the performance.
Yeah, but anyhow, I think it's true that it takes an expert to make
of course
the V&V.
I mean, of course, yeah.
One of the biggest problem is, even for experts, is the geometry that has to be analyzed, especially for CFD. And I think that's one of the biggest problem, and that's something we've been working on, where you could do an actual geometry analysis for any CFD problem in aerodynamics. So I assume the user is going to be an expert, not in CFD, not in the epsilon and deltas and partial derivatives, but rather in the application and they will know what's going wrong in the code. It's like being a good driver. You get into your car and you can drive it. You don't drive off-road or anything like that.
And you don't know how exactly to manufacture a car all by yourself.
Right.
Yeah, you don't need to know.
Yeah, Robin, I was just going to pitch in with a quick suggestion here that verification and validation are probably two components. There's a third component probably also missing here, and that is evaluation. Verification meaning what you put into the code, then you need to make sure that's sensible. What you get out, you need to make sure that's kind of sensible. Validation, you might compare it against experimental or analytical data. Mm-hmm. But there's another one called evaluation. Evaluation is saying, if I have a model which is size X, 10 by 10 by 10, well, what answer do I get when I put in 20 by 20 by 20 or 50 by 50 by 50? And to understand the system's response when you define it in terms of time step or mesh size is probably an important factor to understand how the system responds to what you're applying it to. So I'd also add evaluation. Is everybody hearing some feedback here?
Yeah.
Sorry, yeah, it's here. Sorry.
Okay. This probably answers also to the previous question. The previous question is about maybe what paradigm shifts we expect. I also expect a paradigm shift in multiphysics. So that relates also to this question. And multiphysics is about using CFD with something else. So FE is stated here, but it also means with electromagnetics. It also means with acoustics. I like your description of zero-order extrapolation. The only best indication we have for future is what we have as the current price. Let me go on -1 extrapolation. CFD is actually not just CFD. It's also multiphysics. It includes heat transfer, conjugate heat transfer. We already do that at the moment. And we have confidence in how we do that. So I think with the combination of verification, evaluation, validation, we'll probably get there even with multiphysics, FSI, and everything else that's coming down the line.
Well, I think I agree with you, Fred. The question is, or the issue is, that we should clear on the table. When we talk about democratization, there is no free lunch here. No, this is not a get-out-of-jail-free card where we can throw responsibility to the wind and just release code that's packaged in a way that everyone, quote unquote, can use it. I mean, it actually may require more effort on our parts as developers and implementers of tools to position and create these tools that are usable by people who aren't experts, who don't have our level of expertise. Like Patrick said, starting from the geometry and then moving all the way through to getting the results and analyzing the reams of data that we're going to be getting out the back end.
Yeah, I think that there are plenty of examples that real engineers work with every day where it's a go, no-go decision.
Exactly.
And they're just passing some hypothesis through a test that they didn't necessarily design. It could be a standard test, from an engineering standard or a mil spec, and it's a go, no-go. This appification idea gets you to the point where you can have something that the envelope is so small around a particular, very specific kind of model that you can have a lot of confidence in, the previous V&V that's been done on that model.
Yeah, I fully agree.
And I don't think that you should feel what was the word here? Concerned because you might lose your job. I think the pie gets bigger. I mean, I really do believe
Absolutely.
that. I think you got to look at it that way. The pie gets bigger. There's going to be plenty of opportunity for people who want to create these apps for people and for companies and have the expertise to do so. And these are often going to be very specific, well-known kinds of analyses in the democratization side of things. But there's still going to be tons and tons and tons of unknowns, new ground that has to be broken, and you're going to be using, I think, traditional general-purpose CFD tools for that, and plenty of jobs.
If you're designing a drone, for example, and eventually the CFD is going to disappear, and all that's going to be in your mind is the aerodynamics of this drone, how it's going to fly, why is it why isn't it flying? And all of the all the subject matter expert stuff that you were trained in. So the CFD is what you want to disappear, because that's just math, and that's what you want to bring forward is your design. You want to bring forward your application, and that's you. You want to bring forward your imagination. So you want the CFD to go away.
So we will see two major communities around this whole topic. The one is really the guys who develop the codes, which is really, I mean, this is deep math at its finest, I would say. You know, I'm a mathematician, so I'm always proud of all that great stuff which is in the code, right?
Yeah, it is.
But there is the other community, like the real engineers, who do something, who create something with those tools. You know, there are the tool makers, and then there are the tool users. And the tool users, as someone said, they will grow. That community will really grow. We see this huge trend of freelancers recently, which came from hundreds of thousands now into the millions. This is a fun job, you know, to be on your own, maybe with 2 or 3 other friends, and solve really hard problems, and everybody is contributing to that. And that is, again, I mean, for me, this is already democratization. It is not that John Doe would use a CFD code at all. I mean, this is far too complex, and it will take another 10 years until maybe John Doe with a PhD might use that. But yeah, I see that clear trend that CFD is growing, CAE is growing. I mean, the code writers will not really grow very much. There is a very specific skills necessary, but the users, the tool users will grow.
Yeah, it's a little bit like back in the day, you had to program with machine language and assembly language, and now you can use frameworks and APIs, so it's much easier. But you still have to have your domain expertise.
Right.
I don't know if you guys are reading the questions, but we've kind of touched on 3 extra ones there. So I'm going to pick out Genu's question, seeing as he was one of the first people to ask a question, and he's got a few upvotes. But what Wolfgang was just saying there about people kind of freelancing, he's asking if, like he said, a couple of years ago the trend was to use outsourced CFD groups. So I looked after automotive companies. Now it looks like more and more companies prefer to create their own simulation departments. How do you think it will go in the near future? Is that a trend that any of you guys are also seeing, or are you seeing the opposite trend?
Could I start with a very quick answer there, Robin?
Yes.
Yeah, I've been around for about 20 years, which is not a long time really, but I've seen that cycle change at least 3 times. So it's gone from in-house, and then it's gone to external outsourcing, and then it's gone back to internal, and then it's gone back to outsourcing. So a trend is a trend. It'll probably change in 2 or 3 years' time, and we'll see the opposite happening.
I like it. I think that even might be the answer. So I'm gonna take that as the answer actually, and
I didn't mean to kill that one.
No, you didn't. Just
but you actually did.
You've got quite a knack of a concise, excellent answer, Fred.
Well, the good news is if you decide that you want to be a freelancer in this space, I think there's an unlimited sea of business for you to draw from. Out there. So I really wouldn't worry too much about whether companies are on the upswing or the downswing of that trend.
I think the increase of the number of entrepreneurs is also probably very much linked with open source solvers like OpenFOAM. That really helps at the beginning, I guess, from how it used to be. To be able to start with a robust solver without paying anything, basically. I guess that's also a good reason that you have an increase in the number of entrepreneurs.
Yeah, absolutely. What you can see, for example, around OpenFOAM is so new startup companies over the last 3-4 years. I mean, they came up like mushrooms. So I mean, currently we are putting these small, medium-sized companies on our marketplace, and there's a long queue of them now, and all focusing on open source codes. There is a similar trend on bio around the GROMACS code, for example, for molecular dynamics. So that one here in CFD is really pushing forward. I mean, this is open foam, yeah. There was, by the way, a statement from an analyst at the Stanford conference 2 months ago, which basically said that these open source codes, they are growing 2-digit wise these days. And that's another sign for me that many people are trying out this new and easy to get and still challenging to learn. I mean, we have to be honest here. But so that trend, I see that really growing.
I was going to, as we've got a few CFD developers and product people here, I was going to pick the question from Zhizhang Liu. Hopefully, I pronounced that roughly right. That companies developing CFD packages also need to recruit people from computer science and computer engineering backgrounds. But what percentage of people do pure CFD developers account for in a team, and what kind of skills does a CFD developer need to have? Is a CSE degree necessary?
For me, I don't think so. I did a lot of mathematics, a lot of applied math, a lot of ability to solve partial differential equations, ordinary differential equations, things like that, and some level of expertise in programming, such as knowledge of Fortran for older people like me, or C++, Java, anything that run really, really fast on the machine would be great. Even machine language or assembler, if you could do that, that would be great.
Mm-hmm.
Yeah, I also would like to give a comment on that.
Yeah, go, shoot.
Yeah, I think regarding, let's say, the next generation CFD codes and the way we want to deploy these codes, I think it takes how to say, a big bouquet of different people in order to make it work nicely. I mean, for example, we're working with the Italian supercomputing center, which is Cineca, around things regarding parallelization, and it takes really some deep expertise in order to manage let's say the new area of parallelization. So this is why I believe that for sure, I mean, it is not really necessary to have a degree in computer science, but one of the different profiles which at least we do appreciate come from computer science.
Yeah.
So as a kind of a developer and a releaser and a supporter and maintainer and tester of CFD codes, and it's open foam, so it's been mentioned a few times this morning or this afternoon already. That's kind of interesting. Yes, we do have computer scientists that are on the staff, but open source is really interesting because then it opens up a community, and we don't stop with staff. The contributions coming from the community, from the people that are expert, as Karen said, that and others have said here, there are so many people who are experienced with this very complex system of architectures that they're very willing to help, even with open source like open foam. So that's where community actually works really well. You don't always have to have the expertise in house, and with open source, it just encourages the community to engage there.
I think one of the things I'll comment regarding the way the question is phrased, it says, what percentage of people do pure CFD developers account for in a team? I don't think that's really the way to look at it in terms of skills. Don't look at it in terms of, do you have a certain toolbox in your brain that you can draw from based on your degree or whatever. It's more about, do you have the aptitude for programming, and do you have that logical mindset? We've had engineers, mathematicians, computer scientists, working on software. And I'm going to say this, even though, and I don't mean it to close doors, but in a perfect world, we kind of find that engineers who can program are our preferred way to go, because it gives them the understanding of the physics in addition to the programming technologies to pull things together. So the question is, is a CSE degree necessary? No. What kind of CSE skills does a CFD developer need to have? Well, some developers just need to know the numerics. Some need to have a good feel for user interface and user experience. Some need to understand infrastructure and back-end coding and scripting. And it's a fairly broad mix of skills, especially when you talk about the broader product. A CFD product, software product, is not a program. The program may be at the center of the product, but everything else that's built around it requires skills beyond simply being able to get in and program in whatever your language of choice is.
Right. Yeah. Mm-hmm.
I agree with that.
Mm-hmm.
Oh, we're in danger of all agreeing again. So time's pressing on, and there's a couple of I'm being a little bit being a bit selfish, because there's a couple of questions that I'm quite interested in, seeing what you guys think. First one is from Rahul Joshi, and he's asking, how can CFD play a big role in the healthcare industry? And I'd kind of like to broaden that out as to what industries do you think CFD could play a big role in that it isn't really now? Or it's just taking hold, and has it become stagnant in some of the sort of more classical areas like automotive and aircraft?
Well, I would say definitely it has not become stagnant. I understand that people smarter than me have made comments that maybe it has in certain areas, but I think that it's still evolving in the traditional spaces where CFD plays, whether that's aerospace or automotive. I think the questioner picked, by citing healthcare, I think that's a great opportunity for CFD to be applied, because, just looking at the panel, those of us who have more gray hair than the others, we're all getting older. We're all going to need artificial organs, many of whom operate in the fluid field, like lungs and heart valves and all sort of things. So someone's going to need to design and simulate those things.
Yeah, I'm with you, Jeff, by the way.
Yeah.
But and the
Good
interesting
point.
thing there is that
Good
they
point,
do a
yeah.
lot of things that are patient specific. It's not like it's not like the heart or the lungs come in one model like a car that they crank out thousands of. It's like, patient A has a certain heart valve arrangement. Patient B has a different one. Patient C. So that poses some very interesting challenges for CFD.
Yeah, I think so. Again, it goes back to the geometry of the problem. For example, you can take an ultrasound of a patient and get their heart arrangement, their blood vessels, and what you need to do is to be able to just get something that will automatically analyze that geometry, and you could get the fluid going through. Secondly, the person operating the CFD package would be a physician. So the physician is the main expert here that would be able to analyze the result of the CFD and then plan an operation or something to mitigate the problem that the patient is having. So we need to design things that are automatic, that a physician can use their best knowledge to use effectively.
If we're going to rely on physicians to actually be running CFD in healthcare, we're all doomed.
But they have to. They have to.
Anyone else on the sort of upcoming industries, or is it all about healthcare?
We live in a fluid. Just living on the Earth, we are immersed in fluids. So it's the biggest application.
So I worked for a CFD company for about 9 years when I was much younger, and I I really believed that everything was a CFD problem. I would ride down the street and I'd see an electronics box hanging on a pole and think, oh, it must be generating heat. It's got to go somewhere. That's a CFD problem. So, yeah, I mean, I really do believe that anytime you've got fluids, liquids, gases.
You're familiar with Maslow's hammer, aren't you, Jeff?
Maslow's hammer?
Yeah.
What's that? Everything looks like a nail?
Yeah.
Mm-hmm.
I've got two other trends. One is building services industry, and the other one is oil and gas. Just to chip another two in, they're kind of up and coming.
Cool. Well, I'll move it on then to the next sort of. There's a couple of questions around this actually. To go into AI or deep learning. Do you think deep learning and AI, which is a fairly hot topic at the moment with Google playing AlphaGo and DeepMind and things like that, do you think those sort of techniques can play a role in CFD? Some of the more human-driven activities, as Alessandro puts it, such as pre- and post-processing. I was wondering if it would play a role in, say, optimization. Maybe Haysam could come in on something like that.
Yeah.
But do you think AI or deep learning can play a role in pre- and post-processing to start?
Yeah, well, regarding pre-processing, I don't. I'm a little bit more skeptical because I think there are other technologies which can make the difference there. But regarding post-processing, I think especially if you want to go towards cloud computing and the generation of massive data, I mean, it is not viable that all this data should be post-processed by a human being. And then there's, I think, a part of the general, let's say, just this aspect about covering more work by the computer. I think there are a bunch of very crucial tasks which our community should learn how to deal with. For example, what do you do if you have a CFD model which predicts the contrary of reality? I mean, it happens, and it happens a lot of times. Huh? No. You see, normally there's a big stall in this situation, and I mean, it takes a huge effort to get out of this because it takes some very detailed experiments in order to get to know why your CFD model failed to predict at least a trend. And I think there's really space for artificial intelligence, also in order to know about the critical tasks within your CFD code. In order to check your models, your implementations in your CFD code, and to have a track out to give you an exit strategy if you have too much data, which maybe is conflicting with each other.
I think it might be a good application, again, back into the medical field. Deep learning, I think, is a fancy way of saying neural networks, something that we've been working on for several years, maybe a decade or two. And I think they have done some work back then, a few breakthroughs. I think every 5 years or 10 years they make a breakthrough in neural networks / deep learning, like they were able to use it to process bank checks, and now, I mean, you write a check, and the computer will process it. And now Google, I think, is trying to take it further. So if you have something like that, and you could scan somebody, get their geometry of their arteries and heart, and then do a CFD code that runs thousands of scenarios, then you probably could use something that the doctors program in their knowledge into the neural network, and then it could pop out saying, hey, don't do this because this is the current situation in this patient, or proceed as planned, that type of thing.
I'm more than willing to try artificial intelligence on pre-processing because apparently to date, human intelligence hasn't been working all that well. And I wonder how many people I've pissed off with that comment right there. But seriously, AI is one of those terms that has been genericized to the point where it's almost meaningless to say, I'm going to apply AI to X. I was involved in some experiments to try to apply AI to pre-processing in the late 1980s. I'm not saying that it's a foolish idea. I'm just saying that we have to be much more specific in terms of what is it exactly we're going to try to accomplish in using what kind of tool. Because AI, again, is such a generic term anymore, I don't even know what that means.
Mm-hmm.
Yeah, I think I was quite impressed by some of the deep learning aspects that Google were putting out recently. But the problem that I saw with it was that the feedback loop was too long. So you could get something to mesh something and then solve it and see what the answer was and move towards a particular mesh. But doing the solution, that's going to take too long. It's going to take too long to learn what to do. Too much power to learn what to do. To then how much of that carries over when you make a decent sized geometry change or something like it doesn't seem very efficient for something like for CFD at the moment.
Yeah, I think if the meshing is automatic and you can mesh an actual geometry, then what deep learning will do is to just interpret that data to some extent. So something has to be mechanical, and then the machine would then get the results. I think artificial intelligence, neural networks, deep learning is good at figuring out a trend or. And I don't know anything about artificial intelligence, but what I've read, I think it would be good for just taking an expert, replacing an expert in interpreting the data.
So I also seeded another question with the panel, which I again quite interested to find out. We've only got 10 minutes, so and I don't want everybody just saying I'm going to do the same again. But I asked, knowing what you know now, what CFD business would you start if you were to start over? I'm quite intrigued to see if anybody has anything interesting to share with us on that, or if you just hey, Sam's laughing, he must have something.
No. Maybe we would start a pizzeria.
I would have listened to my mother and become a doctor or a lawyer.
CFD in the healthcare space, John.
Mm-hmm.
Maybe it's a lack of imagination on my part, but I can't imagine working on anything other than pre-processing, especially since it really is the long pole in the tent right now. It's the place where, and I know I'm biased, is where I think we could have most impact on an engineer's use of CFD. So sorry, I violated your condition and said I wouldn't change anything. But
no, I
think that almost every 5 years you have to start in your CFD business, because 10 years ago I was doing something else in CFD, and then the decade from about the end of the end of 2009 to now I'm doing Navier-Stokes, and then I think I have to start something new for the next 5 years. So you cannot say, hey, I'm going to continue the same CFD business. It's just you have to look at what the kids are doing. They have smartphones. They live by their smartphones, and what's the most powerful computing platform that's going to be available in a few years. So that's where you have to start. Who are going to be the customers? What platform they're going to be using? Is the smartphone going to be a small supercomputer? If yes, then that might be the next CFD business.
Well, I'm not smart enough to start any to write anything or to develop any code. So I'm going to assume in this imaginary world that I'm starting a small services business with almost no money. I'd buy a license, a space claim to handle all my model geometry manipulation tools, and I'd use OpenFOAM as my main solver. Not sure what I'd use as my preprocessor yet. Probably talk to John Chauner about that for a good. You beat me to it, John. But that's what I would do, and then and more importantly than all of that, I would pick a niche. So let's just say it's valves. I think there's plenty of opportunity out there. That's just an example. I would be the valve CFD services guy.
Yeah. So same here, and it really depends.
You can't do valve CFD.
So
Yeah.
do you hear me?
Yep, absolutely.
Oh, okay. No, I'm sorry. I thought I got off again by technology. So it really depends. If you want to just do a beautiful small business on your own or with 2 or 3 friends together, I would really pick a niche, as Jeff already mentioned. There is so many great things in industry which need good, solid CFD results, and you specialize on that. This will feed your family and friends, obviously. That's one thing. Or, I mean, if you are like a youngster and you want to get rich within 5 years, then you really have to bet on the bigger trends. I mean, as kind of Patrick said, so smartphones, for example, CFD for smartphones, and I know that already is coming now, but you know there are these waves of the bigger trends, and when you are early enough and take CFD and throw it on a new trend, like quantum computer maybe one of those, then you can even create something really big.
Yeah, I think CFD for smartphones is not as easy as it looks because I don't think the kids want to pay thousands of dollars for cloud computing. So it's a little trickier than that, but they still want to use their smartphones.
Yeah. So I mean, yeah. So what works certainly now is use your smartphone as your front end and connect it to a cloud.
Yeah. That's not going to
so
work.
do all the beautiful pre and some high-level post-processing on your smartphone. It is powerful enough, and everything else, then throw in the cloud.
Yeah, but the cloud is expensive, so kids don't want to do that.
Yeah, it depends on. I mean, it's all. It depends on your requirements.
Yeah.
You dictate the price at the end of the day. I mean, if you want to do a big thing, then it's expensive. The little things today. I mean, renting a server with 32 cores is $50 today a day.
Okay.
That's not expensive.
Not expensive.
At least not for me. Okay.
I would be going in the other direction, Robin. That's multi-physics. So CFD is not an island. It's connecting with acoustics. It's connecting with FSI and structures. It's connecting with heat transfer. And in the end, we're not building components. We're building whole machines and vehicles. So that's probably where I'd connect it. Having a CFD expertise is understanding that we're not an island and we're connecting with many other things.
So then you need at least a team for that. Multi-physics already says it. You need multi-physicists.
Can I give you a call later?
Okay, I hear you. Sure.
Yeah, so just to add something about this discussion, this topic. So we're in the wind industry that can be seen as a niche, but it was not a bet because we were there before starting our own company, and we knew that there was this requirement. So if I was to take a call on what would be our next industry to work on, of course we would first focus on the same scale. So we will talk about the atmospheric boundary layer. So that, of course, it's a faster time to market, and we would probably go with something like air pollution or drones, but a problem which is basically in the atmospheric boundary layer. So we stay in the same physics. I
like it. So some people have stayed where they are. Hey Sam's off to open a pizzeria, and he'd probably make the most money out of the lot of it.
I'll invite you all.
We're pretty close to time now, guys, so I will just say thanks to everybody. Thanks to everybody watching. I've got a little number down the bottom, and I don't know if anybody else can see it, but at least the people watching outnumber those on the panel, so that's all I'm going to say. Yeah, thanks, guys, for showing up, and I hope that people watching got something out of it.
Thanks.
Yeah, thank you,
Thanks so
Robin.
much.
Thanks,
Thank you.
Thank you so much. So,
Bye-bye.
Enjoy,
bye-bye.
everyone.
Yeah.
Bye-bye.
Bye, Robin.
Bye-bye.
See you soon.